full-size tandem with the pedals, and then I realised because that other one worked so well and it was so stable that we could just extend it a bit longer and put the extra pedals in. We made it a little bit wider, not so much for stability, but just so that the wheels could turn more, so that you get a smaller turning circle. And with that we also learned that because it's a longer wheelbase, you actually need to gear the steering up so that the steering turns more than what it would with a solo to allow for the length of the machine.
All right. Ian, as you know, we have your tandems, Steve and I. And it's the greatest thrill as a woman because I'm in control of everything. I'm in control of the steering.
And why should the riding be different?
Yeah, I'm in control of the steering, I'm in control of the braking, I'm in control of pretty much everything.
But I've since added a brake to the back so I can have some control.
Ian, do you build what I call a differential input so that the two riders can pedal at different speeds? Or is it like an upright tandem that both riders have to pedal at the same speed?
Well, this is a most interesting thing because I'll tell you a little story about that. We built a tandem for two German guys who came over to ride around Australia, and the thing was that one of them was a big beefy sort of guy and the other was, you know, as thin as a rake, and the big one wouldn't go anywhere at any more than about 60 RPM, whereas the thin guy wouldn't pedal at anything less than 100 RPM.
So you had to do a differential for these guys?
No, what I did was I simply changed the chainring on the front.
Oh, okay.
And I thought, problem solved. But then I had another problem. The other problem was that the big heavy guy wouldn't go on the front, he would only go on the back. And not only that, they had two lots of panniers. So I had to extend the rack on the back to take these two lots of panniers, and then two lots of panniers wasn't enough. They had two backpacks on top of that as well. And then they said, this thing isn't very stable. So
Would you be on the back end with the little guy at the
and then silly me thought, oh rubbish, you know, I'll get on and give it a ride. And anyway, I go around the corner and of course the wheel comes up like this, whoops, and ended up going over the gutter. And then I said, so, well guys, tandem ain't going to work for you. And my wife was away at this time, and I said, well, we've only got one silo, so we'll have to build you another. You know, you'll have to stay with us or something. And my wife comes home and finds these two Germans camped in the lounge.
Surprise, we have gas. Oh, that's funny. But so it's sort of like the independent pedal system that I've seen actually on my Screamer. They used to have those, where the front person could, so they could, coast. Right, independent coast really is more like it.
Well, there's quite a lot to it because what I find is that the tandems work best when you've got the pedals 90 degrees out of phase, so that when the front one's got the maximum power, the other one is in a dead spot. Now, one of the main advantages of this is that it lowers the torque going through the transmission. So you only have half what you would have if they were both in sync like they are on a normal. They're normally both in sync on a normal bike simply because you need to have your feet up when you've got the thing banked over. That's really the only reason why you have them in sync. So normally we have the cranks 90 degrees out of phase. Now if you have any sort of independent system, then you're not going to kick those like that. And the other thing is, I find that if you've got those directly coupled, then you get very good communication between the front and the back. And I know when I've had a really good stoker on the back, I hardly notice that they're there, you know, because they back off immediately when I do and put the power on when I do and so on. So I think the communication is better. So the other thing I would say is that sometimes people tend to have different leg lengths, and I think for that purpose it's better to change the crank length than it is to change anything else. So I think all things being equal, if you can have it so that, you know, you're coupled together in in the normal way, then that's the best way to go.
Well, that's the question I was going to ask. Is in the front you have, of course, the moving boom.
Mhm.
What do you have in the back for different stokers?
Well, what we have on the back is that this crank shell here is clamped to the main boom, so it slides.
Oh, okay, so the
slides
whole
along.
Yeah.
crank goes.
The whole
Okay,
thing
that's
will
cool.
slide, yeah.
That makes sense.
In fact, this will slide so far that you can put a child on the back there without needing any kiddie cranks or anything like that.
That's cool.
Mm.
I like it. That's my fault.
So this was the next machine that we built. And this is a GTO, so what we had here was this SMS coupling in the middle of the frame. So once the seat's taken off, then the frame can be separated, and the advantage of this is that once the frame is separated into these bits, then you can pack it into a case for airline travel or something like that. So
I never did that with mine.
no, you probably never needed to do it, but it's
Yes, it's couplers.
yeah.
Makes it better for shipping also.
Yeah, that's right.
Smaller the box.
Yes.
The next thing we did was that we found that, especially in this country, there was a lot of people that would use their bikes or their trikes mainly for enjoyment, you know, or for exercise rather than for transport like we'd used them for. And the typical mode of operation was you put your bike on your car and then drive to somewhere where you wanted to ride around in a circle and then ride back again. And we found that there was some trikes being sold here cheaper than ours that, you know, for that particular purpose. So we decided what we would do was that we would have the trikes made at a slightly lower specification and have them made in Taiwan rather than have them made in Australia. And the other thing we decided to do was to make them so that they folded up so that you could put them in the boot of a car. And this factory here is a factory in Taiwan. What we found was that these guys only work in steel, whereas one of the other factories that we were looking at that did the assembly would only work in aluminium. So we ended up getting these guys to make them. Now, the way these guys would work is that they would have the things all tacked together, and there'd be one guy here welding, and he would only do 2 or 3 welds, and then he would pass the frame on to the next guy. He would do a couple of 2 or 3 welds, and then on to the next guy, and so on, so that each guy would only do 1 or 2 welds on the frame. And this way they got really practice, so you know, the welding was better than what I'd seen on anything else, and that's why we got these guys to make the frames for us.
Are your frames robot welded now?
No, they're hand welded. These guys are all hand welding. They're all TIG and they're hand welding. So they've got a big roll of wire underneath the bench and just an electrode, and it's fed in like that.
So how many of your trikes are made in Australia? How many?
Well, what we do is we operate in a number of different ways. One is that we have machines which are fully assembled in Taiwan, and then we have some frames built in Taiwan which are sent to us, which we powder coat and then we assemble. That gives us more flexibility, and we use the lower volume ones for that. So trikes like the GT3 and the GT5, which are our highest volume trikes, are made in Taiwan, and also the Anura, which what happened with the problem with doing it this way was that this factory only makes frames and nothing else. So we would have to get the frames made here, then we would have to get the frames shipped to this other factory. This factory here only works in aluminium, but they assemble as well. So we would have to get the frames made in in Maxwell, which was that factory, and then they would have to be sent to Pacific. So you'd have to get the scheduling right between both of them, and that was a bit of a problem. So when we came to do the Anura, we decided to make that one in aluminium, so this factory then did it completely.
What sort of cost difference would there be between an aluminium frame and a steel frame?
I'm not exactly sure. I think that you probably add something like about 10% to the cost of the whole machine, because the frame's only part of it. The greater cost is in the components rather than the frame, depending where you have the frame made.